Welcome to Rise Study Solutions. Let's discuss the topic named arithmetic progression. It's very simple. Look at this picture, friends. Here I used 3 matchsticks to build one triangle, and I used 5 matchsticks to build 2 triangles, and I used 7 matchsticks to build 3 triangles. So I can write this as a progression, that is 3, 5, 7. If I want to increase the number of triangles, I will place 2 more matchsticks like this. So I get 9. If I am repeating this process, I will get 11, etc. such things. So this is an example of arithmetic progression with the common difference 2, because 2 is adding after each of the sessions. That is, the distinguish between the consecutive term is 2. That is same all here. So that's why I'm telling this is an arithmetic progression. Let's consider next example. Look at this rectangle. Here I used 4 matchsticks to build one rectangle, and I used 7 matchsticks to build 2 rectangles, and I used 10 matchsticks to build 3 rectangles. So I can write this is also as a progression, that is 4, 7, 10. If I want to increase the number of rectangles, I will place 3 more matchsticks like this, and I get 13. If I am repeating this process 16, it will repeat like this. So this is also an arithmetic progression with the common difference 3, because 3 is adding after each of the sessions. That is, the distinguish between the consecutive term is equal in all the cases. That is the major character of arithmetic progression. That is, the distinguish between the consecutive term should be equal in all the progression. There's a good fact from this picture, that is, if I am building 2 triangles separately, I require totally 6 matchsticks, isn't it, friends? That is 3 plus 3 is equal to 6. But when I decided to gather these triangles like this, I only required 5 matchsticks and 1 become remained. It is same in the case of this rectangle. Look here, if I build this rectangle separately, I require 4 plus 4 totally 8 matchsticks. But when I decided to gather this, I only require totally 7 matchsticks and 1 become remain. This is same like in your life, that if your mind, your actions, your love, the sharing among you, it become unite, you can make more profits in your life. That is a good fact you can understand from this picture. That is, wherever the unity is, therever the profit. Because all subjects we study for a good purpose, even mathematics also we use for a good purpose. So you should understand that theory from this picture. Okay, let's move to the day-to-day life example that we follow. Look here, 1 hour. 1 day is 24 hours in a day, we know that. And 2 hour. Look here, 2 day is 48 hours in a day, and 3 day is 72 hours in a day. Look here, this process will repeat like this with the common difference 24. That is, to reach 24 to 48, we have to add 24 again. To reach 48 to 72, we have to add again 24. To reach 72 to 96, we have to add 24 again. So 24 is the common difference of this progression. And the progression is begin from this, that we represent mathematically A. A represents the term. Usually A means the first term. Look here, I assigned position to each of the number, that is first position, second position, third position, fourth position, up to nth term. Here n represents the natural number, because each of the sequence have a rank or a position. So n is represent the natural number which we use to assign position of the number. That is, here a, n or xn, which means the first term or the second term, the third term, fourth term, up to the nth term. So this position we represent with a natural number, and it should be a perfect value. Okay, let's consider the other example. Look here, 1 hour is 60 minutes, isn't it? 2 hour is 120 minutes, and 3 hour is 180 minutes. It will repeat like this, and the common difference among this consecutive term is 60 seconds. 60. So 60 is the common difference of the sequence. That's what I represented here, and this is the first term of this progression. And consider the next example, the odd numbers. Look here, The the odd number which begin from 1. So this is the beginning of the sequence. We represent A1 or A, which means the first term, and this is the second term 3 with the common difference 2, and this is the third term with the common difference 2. This is the fourth term with the common difference 2. This process will repeat like this. Okay, consider the other example. Imagine that there is 95 rupees in your hand and you decided to spend after each of the day with 5 rupees. Okay, the first day there is 95 rupees in your hand. The second day you spend 5 rupees from it and 90 rupees remained in your hand. Again you spend 5 rupees on the third day and you have only 85 rupees remained. The next day you spend 5 rupees again and 80 rupees remain in your hand. So here the common difference is minus 5, because to reach 95 to 90 we have to add minus 5. Here the common difference is a negative term, that is to reach 90 to 85 we have to add minus 5 again. To reach 85 to 80 we have to add minus 5 again. So minus 5 is the common difference of this sequence. To calculate the common difference, we subtract the first term from the second term, or any number we subtract from after the next number, that is the current term minus the previous term. That's the way we calculate the common difference here. 90 minus 95 is equal to minus 5. 85 minus 90 equal to minus 5. This is the way to calculate the common difference. Look here, there's a big piece of cake in your hand and this is your birthday. Just imagine. And you cut that cake into 99 pieces and you decided to spend that cake to the needy. At the first time you donate that one piece of cake from it and there is 98 out of 99 cake remain in your hand. Again you spend one piece of cake and there is 97 out of 99 piece of cake in your hand, and again you spend one piece of cake and you have 96 by 99 pieces of cake remain. Here what's the character? Here the common difference is a negative term and the sequence is decreasing. Look here, there is totally 99 pieces were in your hand. Next you have only 98 pieces of cake remained. After 97 piece of cake remained. After 96 cake remained. Here the common difference is a negative term. Then how will you calculate the common difference? I told you, consider any number or any sequence and subtract the previous term in it. That is, if you consider the second term, subtract the first term from it. That is, look here 98 by 99 is the second term and the first term is 99 by 99, and you got the common difference minus 1 by 99. So this is the common difference of the sequence. This is equal in all the cases, that if you consider the third term you subtract the second term from it, and you consider the fourth term, subtract third element from it, and you get the same result. So this is the character of arithmetic progression. The one common number is adding repeatedly again and again. That is a major character. Or you may say the distinguish between the consecutive term is equal in all the cases. This is the basic role of arithmetic progression. We will discuss more details in after sections. Just continue this watching of